This video covers Trig P.9 Part 1 and Pre-Calc 1.8. The topic for today is going to be two different things, both dealing with functions, but the first one is combination of functions, so adding, subtracting, multiplying, dividing functions. And then the second thing is composition of functions. When we say composition of functions or composite functions, that's when we plug one function into another. And a lot of times when we are dealing with combinations of functions or composite functions, we're dealing with usually what we label the f function and the g function. Now, we may also have an h function. We can come up with lots of different names for our functions, but this is just a labeling mechanism. Okay? Understand that what we're used to seeing is these as y equals. This time, though, instead of saying y equals and y equals, we're going to label one the f function so I can separate it or identify it from the g function, which, in this case, if I left it as a y, I wouldn't really know which y function I'm dealing with. So again, these are just labeling mechanisms. If I ask you to add the two functions together, all you do is you write it as the first function, the f function, so you're just writing what it's equal to, and you add to that the g function, so x plus 5. And we go through and we use our rules for combining like terms to do so. I've got 4x's here and I add one more. That's going to give me 5x's altogether. I've got a negative 1 here and I add 5 to that. I get a 4. Can't add those any further, so I get my answer. So sometimes you're going to see it written as take one function and add the other function to it. Take the f function and add the g function. You may also see it written like this, where instead of putting the x down twice, they only write the x down once and they say take f and g and add them together. And when they have just an x here, that means you just take the function the way that it is. Eventually what we're going to be doing is we're going to be replacing that with maybe a number. If it said to take f plus g of 2, you would add the two functions together and then you would replace the x with a 2 and then simplify. Okay, so we will be doing that in one of these next examples coming up. Alright, sticking with the same two f and g functions, so 4x minus 1 and x plus 5, now what I want you to do is subtract the two functions. When you are dealing with subtraction, you're going to take the first one, write down the first function, the f function, subtract in parentheses the second one. And the parentheses are going to be important here because it reminds me that I have to use the distributive property. If I wrote it like this, so I'm going to say write not above this because this is not how I should do it. 4x minus 1 minus x plus 5. This is just telling me to subtract the x, whereas the correct way to do it tells me to subtract the x and subtract the 5. So make sure that you're putting that set of parentheses around whatever the second term is that you're subtracting. Okay, we don't want to do it that way. So by doing this, I'm going to end up with subtracting x here and subtracting 5. And now we can combine our like terms. 4 minus 1 would make 3x, and a negative 1 minus a 5 makes a negative 6. So I'd find when I subtract them, I get 3x minus 6. Okay, if I take the same concept here, the 4x minus the 1 and the x plus the 5, and now instead of just saying take the two functions and subtract them, and there's an x there, now there's the 7. So what I'm going to do is I'm going to subtract the two functions, then I'm going to replace the x with a 7. So the first part's going to still be the same. Take the two functions and subtract them. So multiply that in, you get 4x minus 1 minus x minus 5, and you should get the same exact answer, okay? But this one says to take it a step further. Now you need to plug in a x equals 7. So I'm going to plug an x equals 7 into the 3x minus 6, so it'd be this, 3 times 7 minus 6. And when I do that, I end up getting a 15. So pay attention to whether or not you need to replace the x or the variable. Most of the time, the variable will be the x. If you need to replace that with a number. If you do, make the substitution at the end. Go through and figure out what you get when you subtract first. And then go back once it's simplified and replace your x with a 7. Alright, this time we want to switch up and talk about multiplying functions. Still, we're dealing with the same two functions, the f function and the g function. When you see a dot, or sometimes you'll just see it as the letters written right next to each other, this means we're going to multiply. Pay attention to the difference though. Later on we're going to see something written like this, f and then an open circle and then a g. So if you see an open circle, that does not mean multiplication. Okay, this says f of g of x, and this means a composite function, and that will kind of be our second topic of the notes today. But a closed circle means multiplication, and a no symbol at all between the two letters means multiplication. This does not mean multiplication. Okay, we're going to come back to that in the second part of our notes today. So I just want to point it out to you now so you don't assume that it means multiplication. Alright, so if we multiply these together, binomial times a binomial. Notice that I specifically put them in parentheses so that now I can actually FOIL them. So if we FOIL, the first terms make 4x squared, outer terms make a 20x, inner terms make a negative 1x, and finally the last terms make a negative 5. Again, we combined our like terms, 4x squared plus 19x minus 5. What a lot of students will do is they'll write it like this, and then because they don't put the parentheses around it, they don't automatically see that this is a FOIL problem. So please write your multiplication as parentheses so that you know that you're supposed to FOIL, and don't do it that way. Okay, last one is dividing functions. So f divided by g, put f in the numerator, g in the denominator. Simplify if you can. Now, what I notice a lot of times what students will do on a problem like this is they will make a very common mistake. In order for me to be able to simplify this, there has to be one number or one variable that will divide into every part of this. And between a 4, a 1, a 5, and a 1, there is no greatest common factor other than 1. So dividing by 1 isn't going to do anything. Not all of 4 of these terms have an x, so I can't cancel an x out. A lot of students will do this. They will say, these x's cancel out. And they don't. They don't cancel out. So if you can reduce, reduce. If you can't, that's your final answer. Here's an example of something you could reduce. I know I can reduce this because what will happen is, I'll just draw a line here to show you that this is a separate problem, as I can factor out of the numerator a 3. That would leave me with this. I can factor out of the denominator also a 3, and that would leave me with this. Now I can say these 3's will cancel each other out because they're not part of a binomial anymore. They're a factor on the outside. So I could factor this down to say that it's just x plus 2 over 9x minus 1. Whereas this one I can't just cancel out the x's. I can only cancel them out if they became factors that I could pull out individually. In other words, really what I can do is I can divide each of these by 3 to reduce it. Continuing to look at division of functions, take the f function, which in this case is the square root of x minus 3, and divide it by the g function, x minus 5. Again, ask yourself, is there something I can divide out of all of this? Well, if this x minus 3 is underneath the radical, I can't just cancel anything out. I have to be able to take something out of the radical to be able to cancel it out. So for this problem, you can't reduce it. That would be your final answer. But if I ask you to change the problem to g divided by f, put the g function in the numerator and the f function in the denominator, you can't leave your answer like this because it's not simplified in terms of rationalizing. So we'd have to rationalize this by getting the square root to get out of the bottom. When it's a square root, you can just multiply it by itself. But you must do that to both the numerator and the denominator. So I'll do the denominator first because that's the easiest. When you multiply a square root by itself, it just becomes what was underneath the radical. So square root of x minus 3 times the square root of x minus 3 is just x minus 3. In the numerator, when you have something that is not underneath the radical times a radical, you kind of just smush them together. and you just put this x minus 5 outside of the radical. And then you write your radical next to it. Again, ask yourself if you can simplify anything. You cannot just cross out these x's because they're both part of a binomial. You have to be able to pull out a factor to be able to cancel them out. You can't cancel out this x minus 3 and this x minus 3 because that's underneath the square root. So that would be my final answer for this.